When you think of the solar system, how many planets come to mind? 8, right? Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. But what if I told you there might be another planet hidden beyond what we can currently see? There is an intriguing possibility of a mysterious Planet 9 orbiting in the farthest reaches of our solar system. In 2016, astronomers Konstantin Batygin and Mike Brown presented a groundbreaking study that changed how we view the outer solar system. While analyzing the orbits of small objects in the Kuiper Belt, a distant region filled with icy debris beyond Neptune, they noticed something unusual. These objects appeared to move in a coordinated way, as if they were being influenced by the gravitational pull of something massive. This wasn't a small anomaly. The pattern was so pronounced that it couldn't be easily dismissed. Batygin and Brown hypothesized that this gravitational force might be coming from an as-yet undiscovered planet. They dubbed it Planet 9. Based on their calculations, this planet would have to be extraordinary, around 5 to 10 times the mass of Earth, making it a super-Earth and orbiting the Sun at an astonishing distance. To put it into perspective, it could be located 400 to 800 times farther from the Sun than Earth is. Such a distance would place Planet 9 in an incredibly long and elongated orbit, taking thousands of years to complete one revolution around the Sun. If true, this would be a game-changer for our understanding of the solar system structure. It's not just a question of finding another planet. It's about rewriting the story of how our solar system evolved. You might wonder why we can't simply point a telescope at the suspected region and snap a photo of this elusive planet. Unfortunately, the reality is far more complex. Planet 9, if it exists, would be so far from the Sun that it barely reflects any sunlight. This makes it incredibly faint and nearly invisible to most telescopes we have today. Detecting it is like trying to find a single dim flashlight in a pitch-black forest the size of a continent. Another challenge lies in the sheer size of the search area. The sky is vast, and pinpointing the exact location of an object so distant and faint is akin to searching for a needle in an interstellar haystack. Additionally, Planet 9's proposed orbit is highly eccentric, meaning it could spend a significant amount of its time in the darkest and most remote parts of its path, further complicating efforts to spot it. Moreover, ground-based telescopes have limitations in how much detail they can capture when scanning the outer reaches of the solar system. Although space-based observatories like the James Webb Space Telescope are designed for high sensitivity, their focus is often on specific targets, leaving wide-area searches challenging. However, astronomers are continually refining their models and simulations to narrow down where Planet 9 might be hiding, giving hope that its discovery could be just a matter of time. The most compelling support for the existence of Planet 9 comes from the peculiar alignment of objects in the Kuiper Belt. These icy bodies, far beyond Neptune, have orbits that cluster together in an unusual way. Normally, we would expect their paths to be more random, but instead, they appear to be shepherded by the gravitational influence of a massive, unseen object. This kind of orbital alignment is hard to explain without invoking the presence of something substantial pulling the strings. Simulations of the Kuiper Belt, conducted by astronomers, reinforce this idea. By adding a planet with specific characteristics, roughly 5 to 10 times the mass of Earth and located hundreds of times farther from the Sun than our own planet, their models replicate the observed orbital clustering. This suggests that Planet 9 is not just a convenient explanation, but a plausible one backed by detailed mathematical predictions. Further evidence comes from objects in the Kuiper Belt that have highly elongated orbits extending far into the fringes of the solar system. Some of these objects even seem to move in a way that indicates they are influenced by a consistent, distant gravitational source. Without a planet to explain these effects, we are left with far less satisfying alternatives. However, the evidence remains circumstantial. No telescope has yet directly detected Planet 9, and much of the data relies on indirect observations and simulations. Even so, the patterns in the Kuiper Belt are compelling enough that many astronomers are optimistic about its eventual discovery. While the idea of Planet 9 is fascinating, it's important to consider the possibility that it might not exist at all. Some scientists argue that the observed clustering in the Kuiper Belt could result from other phenomena. For instance, the combined gravitational influence of multiple small objects in the outer solar system, sometimes referred to as a self-gravitating disk, could produce similar effects without requiring a single massive planet. Another possibility is that our current observations are incomplete or biased. The Kuiper Belt is vast, and our telescopes have only surveyed a small portion of it. If the observed clustering is the result of observational bias, meaning we're only seeing a subset of objects that happen to look aligned, then the evidence for Planet 9 could quickly fall apart with more comprehensive data. Additionally, some researchers suggest that external forces, such as gravitational interactions with a passing star in the distant past or the influence of the galaxy itself, could account for the strange orbits of Kuiper Belt objects. These explanations, while less intuitive than the idea of a hidden planet, cannot yet be ruled out. Ultimately, the absence of direct detection raises valid skepticism. Despite years of searching with increasingly powerful telescopes, no concrete evidence of Planet 9 has emerged. If it does not exist, it would force scientists to reconsider their understanding of the Kuiper Belt and the dynamics of the outer solar system. But whether Planet 9 is real or not, the mystery has already sparked important advancements in astronomy, reminding us that the quest for knowledge often leads to unexpected discoveries. The idea of lost or hidden planets isn't new in astronomy. Our solar system has a history of planets being theorized, discovered, or even ejected entirely. One of the most famous examples is Neptune, which was predicted through mathematical calculations before anyone had seen it. Astronomers in the 19th century noticed oddities in Uranus's orbit, gravitational tugs that didn't match the known celestial bodies. By carefully calculating where these anomalies pointed, scientists were able to pinpoint Neptune's location, proving that math could lead to monumental discoveries in the cosmos. But there's another intriguing story: the hypothetical fifth giant planet. Early in the solar system's history, there may have been a massive gas giant orbiting alongside Jupiter, Saturn, Uranus, and Neptune. Simulations suggest that gravitational interactions among these massive bodies eventually caused one of them to be ejected from the system entirely, flinging it into interstellar space. This rogue planet theory not only helps explain the current arrangement of planets, but also shows how dynamic and chaotic the early solar system was. These past discoveries and hypotheses remind us that the solar system is not as static as it seems. Planets can appear, disappear, or be theorized long before they're confirmed. The search for Planet 9 could be another chapter in this ongoing saga of uncovering our celestial neighborhood secrets. The quest for Planet 9 is far from over, and exciting developments lie ahead. One of the most promising tools in this search is the Vera C. Rubin Observatory, set to revolutionize astronomy. With its state-of-the-art capabilities, this telescope will survey vast portions of the night sky with unprecedented detail and frequency. It's designed to detect faint, slow-moving objects, making it the ideal candidate for finding a distant planet like Planet 9. Additionally, advancements in computational modeling are narrowing the search. Astronomers are using powerful simulations to refine the potential orbit and location of Planet 9, focusing on specific regions of the sky. This targeted approach means future observations will be more efficient and effective. Space-based telescopes, such as the James Webb Space Telescope, could also play a role. While Webb is primarily designed for other tasks, its incredible sensitivity could help confirm the existence of distant celestial objects. Together, these tools form a robust arsenal for solving one of modern astronomy's greatest mysteries. Even if Planet 9 isn't found, the search itself is invaluable. It drives innovation, sharpens our understanding of the outer solar system, and could lead to the discovery of other unknown phenomena, like additional small bodies or clues about the early formation of our planetary system. The story of Planet 9 is one of curiosity, persistence, and the boundless human drive to understand the unknown. Whether or not this elusive planet exists, its pursuit reminds us that the universe is far more complex and fascinating than we can imagine. Every mystery, every unanswered question, pushes us to look further and think deeper. If Planet 9 is real, its discovery will fundamentally alter our understanding of the solar system. If it's not, the journey will still have been worth it, shedding light on phenomena we never expected to find. Either way, the search for Planet 9 isn't just about adding another planet to our list. It's about embracing the spirit of exploration that defines us as a species. Now it's your turn. What do you think? Could there be a hidden giant planet waiting for us to find it? Or is it just a cosmic mirage? Share your thoughts in the comments below, and make sure to like and subscribe for more cosmic explorations. The universe is vast, and our journey is just beginning.